4.4, Part B, talking about uniform motion problems. For uniform motion, we're going to use the formula distance equals rate times time. Before we get to uniform motion, just another example in here. It says the number of games the Oakland A's are expected to win this year is 8 fewer than 2/3 the number they're expected to lose. So I'm going to have win and lose. The win is 8 fewer than 2/3 the loss. There are 162 games, so in total wins plus losses is going to equal 162. Now I'm going to solve by substitution again because it's set up where I can substitute 2/3 L minus 8 for W. And solving, I'm going to add 8, combine those and get 1 2/3, which is 5/3 L. Multiply each side of the equation by 3/5. Cancel that out, and 170 times 3 divided by 5 is 102. So that tells me they're going to lose 102 games. And if there's 162 games total, that means that they're going to win 60. Now for a uniform motion problem. It took Melanie 5 hours to motor a boat 45 miles upstream. And we talked about this in an earlier section about upstream is against the current. So the current is working against you. You're going to subtract the current from the speed of the boat. So we're going to use B for boat speed and C for current speed. And when we go upstream, it's going to be the boat speed minus the current speed. And when we go downstream, it's going to be the boat speed plus the current speed because they're working together. And so it took her 5 hours to motor a boat 45 miles upstream. So I know rate times time equals distance. Upstream rate times time equals distance. The return trip the next day took 3 hours. So the return trip is downstream, took 3 hours, same distance. Now we have a system of equations to solve. We're going to use this to find the speed of the boat in still water and the speed of the current. I'm going to start by distributing. I have 5b minus 5c equals 45, and 3b plus 3c equals 45. So this one is set up to solve by elimination. I'm going to take the top equation multiplied by 3, and the bottom equation multiplied by 5. And when I do that, I'm going to have 135, the right number in there, and multiplied by 5, 225. So when I combine those together, the c's cancel out, and I have 30b equals 360. So when I divide by 30, I get b equals 12. Then I take that 12 and I put it back up into one of the original equations to solve for c. So I'm going to say 3 times 12 plus 3c equals 45. So it's 36. When I subtract 36, I get 9. So then c equals 3. So now my boat speed is 12 miles per hour. And my current speed is 3 miles per hour. Another uniform motion problem. Mary Beth and Michael leave school traveling in the opposite directions. Michael is walking and Mary Beth is biking, averaging 6 kilometers an hour more than Michael. They're 18 kilometers apart after 1.5 hours. What is the rate of each? So Michael, I'm just going to say M is going to be Michael's speed, and that means that Mary Beth is going to be M plus 6 because she's going 6 kilometers more per hour than Michael. And I know that together they go 18 kilometers. And so what I can say is that Michael's distance is just going to be the variable d. Let's just say hypothetically if he goes 8 kilometers, then we know that Mary Beth's distance is going to be 18 minus d. So if he theoretically goes 8, she would go 10 to combine to make 18 kilometers. Remember our equation, our formula, distance equals rate times time. Their time is 1.5 hours. So for Michael, I have distance equals rate times time. For Mary Beth, distance equals rate times time. Making a system of equations. This one is set up to solve by substitution because d equals 1.5 times m. I can substitute this in place of the d. I'm going to have 18 minus 1.5 m. I'm going to distribute and get 1.5 m plus 9. Get my 1.5s together. I'm going to add 1.5 over to the right. I'm going to subtract 9 to the left. So then I get m equals 3. So now I know that Michael is going at 3 kilometers per hour. And I know that Mary Beth is going 6 more than that. So that's going to be 9 kilometers per hour.